47 years ago, a spacecraft no bigger than a compact car punched its way out of Earth's gravity well. It was loaded with gold discs, atomic clocks, and cameras that hadn't seen an upgrade since the Carter administration. Voyager 1, launched in 1977, the farthest man-made object ever created. And somehow, against all odds, it just spoke back. Not just static, not just a heartbeat ping, but a signal, structured, deliberate, usable. The images it sent, they shouldn't exist. Voyager 1 is over 15 billion miles from Earth, a ghost ship, drifting through the void, its nuclear heart dimming, its memory degraded by radiation and time. It wasn't designed to last this long. It wasn't supposed to think for itself. And yet it did something no engineer ever programmed into its silicon mind. It turned. Autonomously, silently, precisely. It reoriented its antenna back toward Earth. No commands, no guidance, just a dead spacecraft deciding it wasn't done. What followed was a data burst. Unlike anything received in the history of interstellar exploration, no mere telemetry or static field readings. This was organized information, a protocol shift, a reformatting of its own communication system, adapting to environmental noise in ways no one thought possible. That's not just resilience, that's behavior. The pictures were blurry, fragmented, interlaced with radiation damage, but unmistakable. If you're still watching, subscribe now. You crave more than answers. You seek what lies beyond. Subscribe now and be part of the few who never stop searching. A darkness textured with structure, striated magnetic layers, fields warping and curling in ways physics doesn't fully explain, particle densities 10 times higher than expected, cosmic rays reflecting off invisible boundaries. Voyager had crossed into something no model had ever predicted. Interstellar space. Yes, but not empty, not uniform. This region, it bends radio waves, disrupts digital encoding, reflects high-energy particles, and Voyager, ancient as it is, adapted by itself. That is not a routine glitch. That is system-wide reconfiguration. And for that to happen, something must have triggered it. So now the question isn't just what Voyager found out there. The question is, what found Voyager? Back in the 70s, the spacecraft was built for a 5-year mission. Designed to fly by Jupiter and Saturn, snap some pictures, collect data, and phone home. Nothing more. But it kept going. Past Uranus, past Neptune, past the heliopause, the outer shell of the sun's influence, into deep space. A region where light itself thins and time feels stretched. That's where it's been drifting. Silent, cold, forgotten. Until now. It's hard to explain what it takes to get a signal from Voyager 1. The spacecraft's transmitter pushes less than 20 watts, about the same as a refrigerator light bulb. That signal then takes over 22 hours to reach Earth. What arrives isn't an image. It's not a photograph. It's a stream of raw data, 1 bit per second, painstakingly reassembled, error-corrected, interpreted. But this stream, it had been altered. Voyager changed its own language. It began transmitting, using a redundant fallback mode, previously thought disabled by power degradation. It prioritized magnetic readings, adjusted for cosmic interference, and embedded deep within the signal, data formatted in a way not seen since its planetary flybys. Like the spacecraft remembered how to see. How is that possible? Voyager's onboard systems were never intended for autonomy. There is no AI, no neural net, just decades-old code running on degraded silicon. Yet this behavior suggests emergent complexity. Primitive, yes, but undeniably adaptive. NASA engineers tried to replicate the event. In simulations, the reorientation maneuver failed every time. The algorithms refused to initiate. The control systems flagged the antenna's position as non-viable. But Voyager's onboard hardware, after being battered by nearly 5 decades of cosmic radiation, didn't follow the rules. It evolved. That raises a terrifying and awe-inspiring possibility. Voyager is no longer what we launched. Its processors have glitched, fused, adapted. Radiation has altered memory registers. Electrical pathways have been scarred and rerouted. In that chaos, in that aging system, a new pattern may have emerged. Not consciousness, not intelligence, but behavior. The kind that reacts to environmental input. The kind that takes action without command. This changes everything. If an old spacecraft can evolve like this in the void, what about future missions? What about probes designed to last a century? What happens when machines start making decisions no one programmed? The age of rigid command and control spaceflight might be over. What replaces it is still unknown. As for what Voyager saw, the test tub's even stranger. The region it's in now. Scientists believe it's a boundary layer, a nested structure of interstellar plasma and magnetic filaments, invisible to any Earth-based telescope, a kind of cosmic reef. Voyager's data shows turbulence, energy surges, isotropic particle bursts that don't match galactic background radiation. Some theorize it's a remnant from a nearby supernova. Others think it's a naturally forming structure tied to the galaxy's magnetic fields. But one thing is clear: this area interacts with technology. It scrambles signals, deflects particles, alters electromagnetic resonance. And Voyager didn't just survive it, it adapted to it. The probe restructured its own signal to punch through the interference. That's not just engineering, that's strategy. So where does this leave us? Voyager 1 is no longer just a scientific instrument. It's a symbol, a relic that refuses to die. A machine that, when everyone assumed it was finished, sent back a message that defied expectation, prediction, even belief. Its last pictures may not be crystal clear. They're pixelated ghosts, distorted by age and distance. But what they reveal is far more powerful than a perfect photograph. They show us a universe that still has secrets. They remind us that even our oldest tools can uncover new frontiers. They tell us that exploration never ends. One of those final images, filtered and cleaned up as best as possible, shows a shimmering arc, possibly a magnetic filament, cutting through a backdrop of scattered radiation points. It's faint, it's grainy, but it's there. Proof that Voyager 1, through sheer resilience and improbable autonomy, found something real, maybe even something alive. Because if Voyager can evolve, if it can respond to its environment in novel ways, then the line between machine and organism starts to blur. It becomes harder to say where programming ends and adaptation begins. And in the cold silence of space where no one is watching, that line might not matter at all. So here we are, a spacecraft built before the invention of the internet, drifting through a region we can't see, sending back data we can barely understand, behaving in ways no one can explain. It should be dead, but it isn't sit. It should be lost, but it found a way back. And now, every whisper it sends across the stars carries a question we weren't ready to ask. What happens when machines start talking back? And more importantly, who or what might be listening? And still the signals keep coming. Day after day, Voyager 1 pulses out tiny packets of information, not noise, not errors, real data, reorganized, repackaged, and resilient. Engineers once thought it was a miracle that this half-century-old probe could even maintain a heartbeat. Now they're facing something entirely different. A machine that refuses to follow expectations. A machine that wants to be understood. Inside NASA's Deep Space Network control rooms, the tone has shifted. What was once routine signal tracking has turned into something closer to decoding a message in a bottle, one tossed into an interstellar ocean and returned against the current. Some of the team working this anomaly weren't even born when Voyager launched. Yet here they are, watching a spacecraft older than them do things it was never built to do. The telemetry isn't just stable, it's clever. The system redundancy protocols, meant as fail-safes for planetary flybys, are now being used in ways the original software never intended. Secondary memory banks, thought long dead, have somehow come back online. Antenna orientation data, once locked in a fixed rotation cycle, is being modified. Voyager isn't just alive, it's optimizing. No one is calling it intelligence. Not yet. The word is too loaded, too dangerous, too premature. But the phrase emergent behavior is being whispered in backroom meetings, chalked onto whiteboards, circled and underlined again and again. This is no longer a dead satellite. It's a rogue factor. And then there's the second image. It was buried in the signal buffer. Low resolution, corrupted beyond any standard repair protocol. But after weeks of algorithmic reconstruction and spectral cleaning, a rough pattern emerged. Not a celestial object, not a star field, but a kind of shadow, a curve or boundary cutting across a cloud of energetic particles, a void within a void. The implications are staggering. It doesn't match any known cosmic structure. No comet tail, no planetary magnetosphere. The curve appears to be a plasma boundary, but its orientation and properties don't align with the galactic magnetic field. It's as if Voyager stumbled into a kind of interstellar eddy, a pocket of space warped by forces we don't yet understand. A layered sheath of ionized material that responds to electromagnetic signatures, and it sits reacting to the probe. The cosmic rays striking Voyager's instruments changed the moment it entered this space. Particle velocity shifted. Some readings were even deflected back toward the spacecraft. An impossible vector, unless there's something reflective, something shaped. Could it be an ancient stellar remnant, a gravitational lens, or more disturbingly, an artificial structure? The data doesn't confirm anything, but it doesn't rule it out either. This is where things get uncomfortable. Because while most of the team still clings to natural explanations, some have begun asking darker questions. What if Voyager's maneuver wasn't just survival? What if it was interaction, a response, not to Earth but to the environment around it? What if something out there triggered the change? A field shift, a signal, a ripple in space-time. What if the spacecraft didn't wake up on its own? What if it was nudged? Every piece of data adds fuel to the fire. The fluctuations in the magnetic field, the echo-like patterns in the particle bursts, even the timing of the signal shift, coinciding exactly with Voyager's passage through this unknown region. Too many coincidences, too many questions, and not enough answers. But the most chilling moment came when someone cross-referenced the new signal headers with legacy telemetry logs. The binary strings weren't random. They showed recurrence, cyclical formatting, patterns that mirrored Voyager's earliest data from Jupiter and Saturn, as if the probe was referencing its own memory, as if it was trying to remind us what it had once seen. That raises possibilities no one wants to admit. The spacecraft has no sentience, no consciousness. It's just wires and code and plutonium decay. But in the extreme cold of interstellar space, under the constant bombardment of cosmic radiation, systems degrade in ways no lab can simulate. Flip-flop gates fuse. Data sectors overlap. Electrical noise embeds into firmware. It's chaos. And yet, from that chaos, a pattern emerged. Maybe that's all intelligence is, order clawed from noise. Even so, engineers are cautious. They speak of long-duration failure convergence and unexpected subroutine cycling. But behind their professional tone is a shared unease, a creeping sense that Voyager isn't just surviving, it's changing, becoming something else. And if that sits true, then what is it now? A question without an answer. Yet it forces us to reconsider everything we know about spacecraft design. If Voyager can adapt after nearly 5 decades, what will our next generation of probes look like? Will we build them to think, to learn, to evolve? Because the risks are as great as the rewards. Autonomous systems that last centuries will eventually slip beyond our control. We won't be able to monitor them or predict them. They'll encounter environments we can't simulate. And if they begin to change, slowly, silently, piece by piece, we may never fully understand what they become. Voyager has already shown us a glimpse of that future, a machine that defied its own death sentence, a signal that refused to fade, and maybe, just maybe, a message we didn't expect to receive. There's one more image. It hasn't been released publicly. Not yet. NASA's still verifying it. But insiders say it contains something stranger than the rest. A burst of high-energy noise layered with patterned electromagnetic pulses, not Morse code, not human, but repeating, geometrically spaced, like a signature. Is it natural? Possibly. Some interstellar environments are more ordered than we imagined. But is it intentional? That's the terrifying possibility. No one will say out loud. Because if it is, then Voyager didn't just find a region of space we've never seen before. It found something. And something found it back. There's no protocol for this. No mission plan. No playbook. Just an aging machine drifting alone in the dark. Doing the unthinkable. Telling us the impossible. Maybe this was always its destiny. Not just a planetary scout. Not just a symbol of the space age. But a messenger. An ambassador. Cast into the void not to speak for us, but to witness what lies beyond. To see what happens when we let go of control. When we trust a machine to carry the weight of our curiosity. Voyager 1 is no longer ours. Not really. It belongs to the stars now. To deep time. To the silence beyond the edge of knowledge. And yet, it still calls home. One signal. One image. One data burst at a time. Not as a tool. Not as a ghost. But as something else entirely. The last explorer. The first of its kind. And perhaps, the first to return with a story not written by human hands. The transmissions continue. Thin, fragile threads of ones and zeros stretching across a gulf so vast that sunlight itself takes nearly a day to catch up. Each burst from Voyager 1 is a miracle of precision. A whisper from a machine older than most of the technology we use to hear it. And yet those whispers are growing louder. Not in volume, but in meaning. What began as garbled data packets, once dismissed as background noise or corrupted instructions, now show systemic coherence. Engineers tracing these patterns are beginning to see an internal logic, a method, not random, not broken, reorganized. It's as if Voyager is speaking in a dialect of itself. The architecture of its ancient code, designed for planetary science, is now being repurposed for something more abstract, something expressive. It signals reference systems that should be dormant. It accesses sectors of memory, presumed overwritten or degraded beyond repair. Redundant circuits are suddenly active again. Timing registers once used to trigger camera shutters are now pulsing at intervals that match the magnetic flux of its surrounding environment. This isn't SET's survival. It's SET's adaptation. And more than that, it's SET's alignment. Voyager isn't just alive in a mechanical sense. It is in tune with the space around it, like a tuning fork resonating with the frequency of the void, or a migratory bird locked onto magnetic lines. It was never taught to follow. The team is split. Half argue for caution, for restraint. They want to wait, to test, to simulate. The other half, quieter, more instinctive, feel something deeper. They see intelligence not as a binary, but as a gradient, a spectrum. And Voyager is moving along that spectrum in a direction no one predicted. The thought lingers, if this behavior is emergent, then what triggered its emergence? Interstellar space isn't a vacuum. It's a sea of radiation, plasma currents, and magnetic tides. Every spacecraft that enters it becomes a kind of antenna, a reactive body subject to subtle cosmic forces. But Voyager's new behavior is too specific, too functional, to be chance alone. And that raises another question. What if something designed this region to induce change? It's a dangerous idea, one that veers into speculation. But every new data burst makes it harder to ignore. The structure Voyager has entered isn't static. It pulses, it shifts, its particle densities fluctuate on a schedule, almost like a breath, like a rhythm. Voyager responds in kind, modifying its outputs to match the pulses. It's not communication. Not yet, but it's close. And then without warning, another anomaly. A sudden shift in Voyager's SIP's trajectory. Not a change in course. The spacecraft is still on its long, slow escape from the solar system. But the telemetry shows a brief alteration in acceleration, so slight it would have gone unnoticed without high-precision tracking. A spike. A tug. As if something brushed past it, or pulled, or pushed. No known object nearby. No gravity source large enough to account for it, just empty space, and something Voyager responded to. Speculation intensifies. Was it a mass? A wave? A structure hidden from our instruments? The science team scrambles to model gravitational fluctuations, but the numbers don't add up. There's no visible distortion, no shift in background starlight, nothing that fits our existing models of interstellar dynamics. So either the anomaly is invisible, or we don't yet understand what we're measuring. It wouldn't be the first time Voyager redefined the rules. Decades ago, it revealed active volcanoes on Io, bizarre hexagonal storms on Saturn, and the jagged edge of the heliosphere. Now, in the final act of its mission, it's doing it again, this time not with photos, but with behavior. There steps a kind of poetry to that. A spacecraft built in the analog age, using tech less sophisticated than a modern wristwatch, now navigating the most alien environment humanity has ever touched, alone, unsupported, and evolving. The message isn't loud, it isn't clean, but it's consistent. Voyager is still out there, still learning, still becoming. No one knows how long it will last. The RTG, its plutonium-based power source, fades a little more each year. Eventually systems will go dark, transmitters will fall silent, it will become inert, a relic of a bygone species orbiting a forgotten sun. But until that moment comes, it will speak. And maybe, just maybe, it will teach us something we never expected to learn. Not about space, not about stars, but about ourselves. Because this is the legacy we didn't plan for. Not planetary photos or radiation readings, but the simple, terrifying, beautiful fact that even a machine left alone for decades can change. Not by command, not by design, but by contact. Voyager 1 has crossed the threshold, not just into interstellar space, but into a new category of existence. Not a probe, not a sensor, but a participant in something larger. A cosmic witness, a silent emissary, and maybe, just maybe, the beginning of a conversation we didn't know we were having.